In this video, we are going to talk about the foundation of hypothesis testing. And we'll talk about some basic concepts and the basic hypothesis testing methods. So the hypothesis testing involves the use of a sample as a means of drawing a conclusion about a population. We have seen this one in the previous PowerPoints that when we calculate the confidence intervals and to estimate a point. Okay, so it's the same idea, the same logic. Is that the process of generalizing from a sample to a population, the use of a sample statistics to estimate population parameters. Okay, so we have the sampling error. We have covered this in the several points. To accommodate the sampling error, we have to use sampling distributions to make a good guess, to make a good predictions. That is what the hypothesis testing basically doing. Now, every time when we see a sample statistic is not equal to a population parameter, or there is a difference, then the difference basically coming from two potential explanations. In order to pick which one explanations, we have to run some statistical analysis. But the two potential explanation, the first one is that it is a purely coming from the sampling error, something that naturally happen that we cannot control. And the second, it is coming from the true difference. Okay, there is a true statistical difference, a true statistical effect between this population parameter and the sample status. Okay, now actually there is a third way to explain, but this is not really quite often mentioned because the third explanation is that the researcher doing something wrong or doing something that is not supposed to do. So we don't really talk about because it's a wrong behavior in doing the research. So we're talking about the two most likely happen, the potential explanations that if the researcher follow the procedure, and those are the two potential explanations. Okay, so the overarching purpose of the hypothesis testing is to determine which of the above explanation is more valid or maybe more possible. Okay, it's not going to be like a 100% correct, but which one is more possible. So the first one, there are basically two steps. The first one is a sample statistic is computed, and the second one use a probability distribution to find out if this sample statistic has a higher or lower probability of occurrence. Okay, so the one thing that we wanted to know that the hypothesis test in future PowerPoints, we will be covered a few hypothesis testing. The way that we decide which hypothesis test we are going to use is really determined by the level of measurement of the variables, of dependent variable and the independent variable. Okay, so this is also another thing why when I talk about the level of measurement chapter or in that PowerPoints, why the level of measurement is so important, because it's also deciding which hypothesis test you should use. Okay, so some basic types of hypothesis testing. These are a very simple table about the basic relationship between the level of measurement and the bivariant test. So we're only talking about bivariant test because in here we're talking about the situation with one dependent variable and one independent variable. Now you have to understand that we are talking about one dependent variable and one independent variable. So sometimes there is a situation that we have the one dependent variable but multiple independent variables. Okay, that will be conducted in most likely the regression analysis. But in this PowerPoint, we're talking about, you see, we put the regression here, even it's in the one-on-one situation, one dependent variable, one independent variable. Okay, so here the table is very simple to read. You have the dependent variable and you have the level of measurement of the dependent variable. You also have the independent variable. You have the level of measurement of independent variable, right? So here you can see if the dependent variable is a categorical variable, independent variable is a categorical variable too, then we are going to use the chi-square, which will be further explained in another PowerPoint. If the dependent variable is a continuous variable, the independent variable is a categorical variable with two categorized, then we are going to use the t-test. Very common that you will see this one, especially in like a psychology or clinical trial, medical clinical trial, something like that. Or if we have the dependent variable as a continuous variable, independent variable is a categorical variable as well, but has three or more, then we are going to run analysis called ANOVA. Okay, here we do not run a bunch of t-tests in this situation, and we will explain further about the ANOVA and the t-test in other PowerPoints. It just lets you know that if the categorical independent variable has three or more values, okay, we are not going to use a few t-tests to decide the results. We use the ANOVA to test the results. Okay, so some example, let me give you some example. For example, this here is like the dependent variable will be a continuous, like a student's GPA. Okay, it's a continuous variable. Student's GPA is a continuous variable, and independent variable we say maybe for the two categorized categorical variable would be like a gender. Okay, male and female students, their average, the average GPA of male students and average GPA of female students, then we are going to use a t-test. But if we have three or more categorized, for example, like a race, okay, let's say white students, African American students, Hispanic students, okay, if you trying to compare their average grades based on the race, like white, African American, Hispanic, then you are going to use the ANOVA. You don't run a bunch of t-tests, okay? But if the dependent variable is a continuous variable, independent variable is also a continuous variable, we are going to use the correlation. Okay, that will be covered in further PowerPoints as well. If the dependent variable is a categorical variable and the independent variable will be a continuous variable, then we will use a regression to talk about that. Now, for the most of the time, since the dependent variable is a categorical variable, we probably use a logistic regression to test it. Okay, the bottom is just give you some refreshment about what is the dependent variable and what is the independent variable. I'm not going to repeat here again. So the very easy one, you see this flow chart is that first of all, you have to decide the level of measurement of dependent variable. Dependent variable, it's very important. You take a look at the dependent variable. Okay, if it's a categorical variable, then decide the level of measurement of the independent variable. If it's a categorical 2, you use a chi-square. If it's a continuous variable, you use the regression. Okay, so if the dependent variable is a continuous variable, again, you take a look at the level of measurement of independent variable. If it's a categorical variable, then we will decide how many categorized in this variable. 2, then we use the t-test. If there are 3 or more, we use the ANOVA. If the independent variable is also a continuous variable, we use the correlation. Okay, so you should remember this one, or at least print this out as your handouts when you try to make sure your decision to run the test or which hypothesis test you are going to use for a bivariant test. Okay, only 2 variables, 1 independent variable, 1 dependent variable. This is good for you to make sure that you use the correct hypothesis test approaches. Okay, so some of the example, like here, compared to males, are females more in favor of death penalty? So the dependent variable will be attitude toward the death penalty, and we measure this attitude as like and dislike. You can see this is a look like, it's a categorical variable, right? Like, dislike, it's a categorical variable. Independent variable will be gender, male and female. Again, this look like a categorical variable. So You have a dependent variable as a categorical variable, independent variable as a categorical variable as well. So what the proper methods you are going to use? The chi-square. Okay. Second, compared to males, do females spend less time in prisons? Okay. The dependent variable will be length of incarceration. We can measure this 1, 2, 3, 4, 5 blah, 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 by years or even months, something like that. Okay. And you can see since it's measured by numbers, so the length of incarceration will be or considered as a continuous variable, right? The independent variable, again, female, male, so it will be the gender, and you can see the gender is a categorical variable with 2 categorized. So here, which hypothesis test you are going to use? T-test, right? So if the question is there any difference among officers with different races regarding the number of traffic tickets they write? Okay, at this place or at this question, the dependent variable will be number of traffic tickets the officer write, and the independent variable will be officer's race. And here we have we use like 4 race: white, African American, Asian, Hispanic, 4 different types of race. Okay, so the number of traffic tickets can be 0, 1, 2, 3 to 10, 11, or like 10,000, something like that. That would be a continuous variable. The independent variable, officer's race, white, black, Asian, Hispanic, that is a completely categorical variable, and this categorical variable has 4 groups, 4 categorized. So what are we going to use? The ANOVA. Okay, so this PowerPoints just tell you which one is the better or which one is the proper one we use, and we'll be talking about ANOVA t-test, chi-square correlation, even regression in the future PowerPoints. Okay. So a few more basic concepts. Okay, one is the probability. Researchers identify the probability of observing a particular empirical result and use the probability to make a decision about what explanation seems to correct. The explanation we already talked about at the beginning of this one. The PowerPoint. And also you should review the PowerPoints regarding the confidence intervals and point estimate. It has some very basic about the probability and why the probability is so important in explaining the hypothesis testing. Okay, so in hypothesis testing, the very most important thing is what is a hypothesis, and typically we have 2 types of hypothesis. The first one we call the non-hypothesis, usually symbolized as a H0. Or some people say HO, but usually I like it's H0. Okay, the non-hypothesis basically talks about there is no relationship between the dependent variable and the independent variable. There is no relationship between the 2 variables. That also means like one cannot impact another. Okay, the alternative hypothesis, it's called alternative, so it symbolized as the H1. So basically, this also can be talked about as a research hypothesis because later I'll give you some examples that it's really coming from the research question, and the research question often decides what the alternative hypothesis will be look like. Okay, so it's basically talk about there is a relationship between the independent variable and the dependent variables. In terms of what kind of a relationship, again, it really depends on what the research question you ask. So the classic example is that this is the hypothesis, the non and alternative hypothesis will be or could be used in like the t-test, okay, because we use the mu, that's the mean of the population. So the non-hypothesis will always be like the mu1 equals to mu2. That means 2 population means are the same. And the H1, which is the alternative hypothesis, there are 3 different ways to say it, okay. The first one means like the population of sample 1 is less than the population mean in the sample 2. The second one means the population mean of sample 1 is larger than the population mean in sample 2. Those two, because they're talking about large, bigger, less, smaller, these are what we call the directional test. Directional test later when we go into the t-test PowerPoint, we will talk about directional tests. Usually we have been talking about the one-tail test. Remember we talked about the one-tail, two-tail before, right? So usually like the t-test or t-distribution is on the left side and right side, right? Negative side and positive side. It could be go either way. But if you use the alternative hypothesis as a directional, which is larger, smaller, bigger, less, then you are talking about the one direction. You pick the direction. So for the first one, it looks like a less, so you pick the left direction, less than a negative direction. So if you pick the second one, larger, then it goes to the positive direction. Okay, or there is another way you say the alternative hypothesis is like there is a significant relationship between the dependent variable and the independent variable. However, I don't know what's the relationship look like. Okay, so I just know that they two are different. The population mean in sample or in population one is different from the population mean in the population two. It's just different, but I don't know what the difference is. So for those things, for those research questions, it can go either way, either left side, a negative side, or either positive side. It can go either way. So in statistics, we also call this is a non-directional test because we don't know the direction, right? We'll be cover this one more time or in details when we're talking about like the t-test or other things. Okay. So again, there are two hypotheses used to state the predictions about whether or not a statistic is an accurate estimate of a parameter. A sample is an estimate of a population, right? The null hypothesis predict that the difference between the population and sample is just coming from the sampling error or chance or the chance variation in the data. So basically means something you cannot control. It's just the nature of the data. So it's not a true difference. Okay. The alternative or research hypothesis talking about no, this difference is true. This relationship is true. Okay. It does have this relationship. That's why they are different. The same logic when we talk as we talk about in the beginning of the PowerPoints. Okay, so the null hypothesis is that the overall or the fundamental purpose in hypothesis testing is to decide whether to accept the null or reject the null. This is very, very important. Okay, even we have the alternative hypothesis, which is H1. We have this non-hypothesis, which is H0. But all the things we do in later, all the other hypothesis testing, whatever we will cover in later PowerPoints. In all the hypothesis testing, the only thing we test is the non-hypothesis, and we only make a decision based on the results regarding the non-hypothesis. Okay, so we only choose to accept the non-hypothesis or reject the non-hypothesis. We don't run any tests on the alternative hypothesis. We only run the test on the non-hypothesis. This is really, really important. Okay, so if we accept the non-hypothesis, that basically means we reject the alternative hypothesis. If we reject the non-hypothesis, that basically means we can accept the alternative hypothesis. But keep this in mind, we never test any hypothesis, any alternative hypothesis in hypothesis testing. The only thing we testing is non-hypothesis, and we only make decisions on whether we accept or reject the non-hypothesis. Okay, so if the probability of the non being true is low, then we reject. If it's not low, it's high, then we can like reject it. Okay, so if the probability of the non being true is low, we will reject the null hypothesis. If it's the true is not low, that basically means null hypothesis may be correct, then we're going to accept the null hypothesis, then we reject the alternative hypothesis. Okay, this is very important. So some of the example I'm going to show you. Compared to males, do females spend less time in prison? Now, first of all, you have to know that what's the difference here, or what's the variables here. The variable is one is the gender, right, male, female, and another variable is the time in the prison, the time or the length of incarceration. Those are the two, right? So the null hypothesis always talk about there is no relationship between gender and prison. Now think this logically. If there is no relationship between male or female um, regarding the length of incarceration, if there is no relationship between gender and the length of incarceration, what will happen? Male and female will spend the same time in the prison, right? If the gender doesn't work or if gender has no impact on length of incarceration, the male and the female will spend almost a similar time in the prison. That's where the null hypothesis is. Okay, females spend the same time in prison like males, or you say males spend the same time in prison like female, it doesn't matter. Okay, and since this is the t-test that we use the population mean female equals to the population mean of male, right? The alternative hypothesis, like we showed in the previously, that there are different ways to ask or to write down an alternative hypothesis. It really depends on the research question you ask. Now take a look at the research question. Compared to males, do females spend less time in the prison? Is there a direction? Yes. The direction from the research question is female spend less time, right? So the alternative hypothesis will be females spend less time in prison compared to males. Okay, but there is a situation, for example, if the research question becomes, is there a difference between male and female inmates regarding their time in the prison? Now, it asks a question about is there a difference? It doesn't say females spend less time. It doesn't say males spend less time. It just say is there a difference, right? In that scenario, the alternative hypothesis become a non-directional test because you can go to the female spend less time than males, or you can go to the male spend less time than females. So it become a directional test. So if it's a non-directional test here, then you are going to use the not equal to. Okay, we don't know, right? We don't know. We just know that they are different, but we don't know what's the direction. So it's a non-directional test. So we use not equal to. Okay. When we're going to make some decisions, whether we reject or accept the noun. Okay, again, here, emphasize, very, very important. We only make a decision on rejecting or accepting the null hypothesis. Okay, but there is always a chance that we make something wrong, right? If you remember the point estimate and the confidence intervals, we never say that, okay, the population mean will be somewhere definitely. Even it's a range, they'll be there. We always say that we have 95% chance we are correct, or we have 95% confidence, right? So in the hypothesis test, when you're going to reject the non-hypothesis or when you're going to accept the non-hypothesis, there will be some type of errors you will also make. Okay, the one we do is we try to reduce the type 1 or type 2 error like we're showing here. But the type 1 error means the rejection of the true non-hypothesis, or the type 2 error means the retention of a false non-hypothesis. Now, I think this is so complicated. I like the plain language. So the type 1 error usually symbolized as the alpha error would be reject what we should not reject. Okay, if it turns out we reject the non-hypothesis, but the truth is that we should not reject the non-hypothesis, then we were making type 1 error. So the type 2 error, or also the beta error, is accept we shall not accept. If we accept a non-hypothesis that we're supposed not to accept, then we were making type 2 error. So this is more easy for you to remember the type 2 and type 1 error. right? Again, type 1 error is something happening when we reject what we should not reject. Type 2 error is happening when we accept something we should not accept. Okay. So hypothesis testing in the textbook, and in the following a couple of PowerPoints, I will use this. Some of the hypothesis testing will follow the procedure in the textbook. In the textbook, the hypothesis testing will always have like 5 steps. The step 1 will be state the non and alternative hypothesis. The step 2 will be identifying the distribution, which distribution we are going to use, and calculate the degree of freedom. Okay. The step 3 is find the critical value. Step 4 is compute the obtained value, and step 5 is make a decision. Now, making a decision is literally, okay, this is literally coming from comparing the critical value and obtained value. Okay, and also often the step 2, identifying the distribution, compute the degree of freedom, is often used to find the critical value. So it's like a one by one. You should do the first previous step in order to finish the next step. Okay, so in the 5th, we're going to make a decision about the non-hypothesis, whether we accept the non-hypothesis or reject the non-hypothesis. Okay, this is a classic textbook hypothesis testing, I guess, in not only in the criminology or criminal justice, but in all social sciences. Okay, this is classic text 1, and in the future PowerPoints, the hypothesis testing will be running like this one. Okay. However, in practice, in the journal articles, research articles, published papers, even books, you don't really see the hypothesis testing like doing something like that. You don't see the paper writing down something like, I'm going to run this t-test and this is step 1, 2, 3, 4, 5, and that's my conclusion. Now, you don't really see that. So in practice, most likely we are going to calculate by using the software, either it's Excel, SPSS, Stata, R, or other HLM, or even fancy ones, expensive ones. We don't really do follow the 5 steps, but still 5 steps is the fundamental logic, things you want to understand it, okay, before you running any hypothesis test in practice. It's just give you a solid foundations to understand the hypothesis testing in practice. Okay, the hypothesis testing in practice is that this is just a refreshment about the confidence level of confidence and alpha level. I'm pretty sure you're already familiar with that. Level of confidence usually set up 95% or 99%. That means 95% chance we are right, 5% chance we are wrong. And also if we set up 99%, that means 99% of the times we are right. Only 1% of the chance that we are wrong, right? The alpha level is the opposite side of confidence. You're probably familiar with this one. If you go through the point estimate and the confidence intervals in the previous PowerPoints, right? 95% confident level means the alpha level at 0.05. 99% confident level means the alpha level at 0.01. It's almost the same. It's actually the same with the previous material. I just give you a little refreshment here. So the alpha level we have usually set up a 0.05, right, or 0.01. Have the somehow we have the it shows the standard for how the extreme the data must be before we can reject the null hypothesis. Now in here in practice I introduce you this p-value. People always talking about the p-value. P-value is one of the things that we use in, or most likely in practice. Okay, so the p-value indicate how extreme the data are. We compare the p-value with the alpha level to determine whether the observed data are statistically significantly different from the non-hypothesis. Now this is a very complicated, but keep this in mind is that most of the software, SPSS data, or even you're using Excel, it comes in out with the p-value. Okay, it calculates the p-value that you can use this p-value to compare to 0.05, which is alpha level, or compare to 0.01, which is 99% confident level of the alpha. Okay, so the fundamental thing is you just need to remember those two. Okay, if the p-value is less than or equal to the alpha level, usually we pick the 0.05. Okay, so we write down like p less than 0.05, then we reject the null hypothesis. So we say it is significant, or because we reject the null hypothesis, we must accept the alternative hypothesis, right? So there is a significant difference, or it is significant. So if the p-value is greater than the alpha level, we usually set up a 0.05. Then we fail to reject the null. We fail to reject the null means we have to accept the null, and we say that the result is statistically non-significant. Okay, keep this in mind. The alpha level 0.05 or 0.01, sometimes you will see 0.001. It really depends on it's just like a common things. Okay, you can't really interpret why we use a 0.05 or not 0.4 or not 0.04 or 0.03 or 0.06. Why is that? But most likely this is just the thing that people go with, most of the social sciences go with, so just keep this in mind. It has some of the statistical background, but we are not going to cover it here, okay? But just keep in mind that in practice you will see lots of the variable, they have the p-value, or the results has a p-value, and you use a p-value to make a decision. Okay, you don't have to round back like here in step 1, 2, 3, 4, 5. Then you eventually go to the 5 to make a decision. Okay, in practice, the simple p-value can let you make the decision. If the p-value is less than 0.05, you reject the null, accept the alternative. If the p-value is bigger than 0.05, you fail to reject the null, so you accept the null. Okay, the null hypothesis. So here is some of the example. For example, if we do the one-tailed test on the positive side, okay, right side is a one-tailed directional, positive directional test. So this places area will be the alpha area. Okay, this will be the alpha area. And the rejection of non-hypothesis area will be anything that is in these areas. Okay, so if the p-value is here, then p-value is within this area, the rejection area, so we are going to reject the null hypothesis. Okay, so here, if the p-value is less than or equal to the alpha level 0.05, then we reject the null hypothesis, because this area is most likely this area will be like 0.05 in proportion, right? If the p-value is less than 0.05, let's say 0.01, so it will be somewhere here. Okay, so this will be lies in the rejection area. This is the positive side. Similar, if we go to the negative side, the alpha level going to here, okay, this area, the proportion will be the 0.05, right? Again, the rejection area will be anything like smaller than 0.05. So again, if the p-value is less than or equal to the 0.05, then we reject the null hypothesis. So you can see whether we go into the positive side or we go into the negative side, the logic is the same. Okay, as long as the p-value can be or can be put in this rejection area, then we are going to reject the non-hypothesis area. Now in the two-directional test, that's the same thing. This area is alpha, and if the p-value it lies between those rejection area less than this one, then we are going to reject the non-hypothesis. Okay, same logic. It's the same. So the relationship between alpha level, p-value, and significance. Okay, I mentioned those things a couple of times, but there is a little bit of summary for these PowerPoints. First of all, in practice, we often set the alpha level at 0.1, but it could be set up at 0.01 or 0.001 or even 0.0001. It depends on your research and questions, your sample of the data or the sample size, something like that. Okay, and in practice, when we use the analysis software, p-value is often the one that we pay attention to. I mentioned this before, is that In the software, we are looking upon the p-value to make our decision instead of take a look at the observed value, critical value, make the decision based on comparing observed value and the critical value. No, we don't do that. So in the software, we just pay attention to the p-value. Okay. So the hypothesis testing in both textbook and the practice should be understood. Again, the hypothesis testing in the textbook is a very classic way that understanding the hypothesis testing, why this is happening, why we reject the non-hypothesis, why we accept the non-hypothesis. Okay, it's very important to lay the foundation for your knowledge of doing hypothesis testing. Once you are so familiar with the hypothesis test in textbook, then when you're going to use the software and when you're going to take a look at the p-value and anything in the software will make a great sense. Okay, whether you're using SPSS, data, Excel, R, then those things will be making more sense. Okay, so you have to learn like both of the ways. Okay, and for bivariant hypothesis testing, usually we have one dependent variable, one independent variable. So the PowerPoints in the future will focusing on the hypothesis test in the textbook. Okay, so I will show you in the future PowerPoints as a step by step how we do in the 5-step hypothesis testing for those bivariant hypothesis testing that typically we will cover chi-square, t-test, ANOVA, and the correlation. Okay, for multivariate hypothesis testing, that means we have one dependent variable, but a lot of independent variables. We just focusing on the hypothesis test in practice. Okay, so this one, the first one is not really common to see in like criminology or criminal justice, or maybe sociology. No, it's not really common because it only involved with one dependent variable and one independent variable. Okay, so you may see this one. You may see people using chi-square test, ANOVA, or t-test in some very basic scenarios. Some of the like psychology trials, psychology experiments, medical experiment, education experiment, they may use very simple hypothesis testing like a chi-square, ANOVA, t-test. Okay, but for us, the most common thing in like a practice in our discipline, criminal justice, criminology, and other some sociology, and psychology as well, right? So if your model gets more complicated, involved with more independent variable, this is the one that we always look at. Okay, this is the one that you often see when you're going to read the academic papers, reports, or even like academic journal articles, or even super academic like books. This is the one you often see. Okay, but it doesn't necessarily mean that we don't have to learn the easy one. We still need to learn the easy one to lay the foundation of our hypothesis test skills and knowledge. Okay, it's not that common to see in the discipline. Okay, that's it for the foundation of hypothesis testing.